G'day everybody, welcome again to another Azure Roundup, Azure Functions, and we've got part 3 with Janhavi and Tukur, who is going to cover off durable functions for us today. So Janhavi, over to you.
Thank you, George, and hi everyone. So this is the part 3 of Azure Functions, and my name is Janhavi Turkar, and I'm going to take you through durable functions today in this part. Okay, so we are going to talk about durable functions. We are going to understand what is the need to have durable functions, and then we look at how we can create the durable functions and different patterns that we can use these durable functions for. So first of all, why do we really need to have these durable functions? Now think of different scenarios. Okay, so first scenario is that let's say that you have to take the output of a function and then use it as input to another function. Okay, so here you'll have to then coordinate the chaining manually if you're doing it through the normal functions. Okay, now we want to be able to implement that easily, and this is where your durable functions can help you. Second scenario, think of if you have to have a function that takes some sort of an event and then parallelizes it into multiple functions. So you can still do that, but how will you know when all the functions have finished executing so that you can aggregate the results and then move on? Okay, so you want to fan out and you want to fan in. So how can you do that? Now, normal functions can be very difficult to implement, but with the durable functions, you can implement that really easily. Third scenario, what if you wanted to do some kind of an extended monitoring on an endpoint? So for example, if you were to monitor the temperature of a remote machine, and then you want to take certain action if the temperature was lower than your threshold, and then you want to do another action if it's higher, right? So you want to do something like that, you want to monitor. Okay, so that you can implement using these durable functions. Another scenario to think about is if you have an API or an endpoint which was running for a long time and your functions, you know that these are short-lived and sometimes you put some serious load on them and it's going to run for a longer time. Now, could there be a mechanism to provide the status of that execution back to the client so that they are not left hanging out, right? Another scenario to think about is human interaction. No, there are a lot of situations where you want to get human interaction, but you cannot wait for the human interaction and you want to do something else. Like, let's say there's an approval process. So in the approval process, you say, okay, manager needs to approve within 72 hours. If it doesn't happen, then I want to escalate to manager's manager. Now you want to check for that. And what if the manager is on leave during that period? Then how can you do it? So this kind of implementation also is really simply implemented using these durable functions. Then if you want to have multiple events, so when you want to listen for multiple events and then aggregate their outcome and decide which job or function you want to run. Okay, so in that kind of scenario also, your durable function will come in handy. So durable functions are basically the extension in your Azure function, which lets you write stateful functions. Okay, so with the help of these, you are going to have the stateful functions, and you will be able to write complex function orchestrations with the help of these durable functions. And behind the scene, this extension will manage the state and the checkpoint and also the restarts for you. And then this is built on the open source durable task framework there. Okay, so this is an open source library which is available on GitHub, which is used to build workflows in code. So this durable functions is based on that open source library. Now your durable functions, they are supported in different languages. So we have got C#, we have got JavaScript, we have got Python, F#, and PowerShell. So C# you can do both compiled and C# library. Same for F#, you can do compiled and C# libraries. Now JavaScript, it's supported only from 2.x version of the Azure functions. PowerShell, it's supported only from the 3.x version of the Azure function and PowerShell 7 runtime. Okay. Now there are different types of functions which are available in these durable functions, and you're going to need them in different situations. So the first function you have is orchestrator functions. Okay, so these you can use your orchestrator function to orchestrate the execution of other durable functions within that function app. So this function, it defines the function workflow using procedural code. You don't need to have any declarative schemas or designers for these ones. Orchestrator functions, they can call other durable functions synchronously and asynchronously, and the output from the call functions, they can be then reliably saved into local variables there. Okay, so orchestration functions are durable and they are reliable. So execution progress is automatically checkpointed when the function is in the await state or when it yields. Okay, so the local state is never lost when the process recycles or your VM reboots. And these functions, they can be long running. Okay, so the total lifespan of the orchestration instance, it can be seconds, or it can be days, months, or it can even be never ending in that scenario. Second function is your activity functions. Now these are basic unit of work in the durable function orchestration. So activity functions are the functions and the tasks that are orchestrated in the process. Okay, so for example, you might want to create an orchestrator function to process an order. So the task involves checking the inventory, charging your customer, creating a shipment. So there are different tasks there. So each task would be a separate activity function in that scenario. So these activity functions, they may be executed serially, or they can be executed in parallel, or it can be combination of both there. Okay. Then the third type of function you have is these entity functions. Okay. So entity functions, they define operations for reading and updating small pieces of state. So there are stateful entities and they are often referred as durable entities. So entity functions are the functions with special trigger type, which is called as entity trigger. Okay. And then you have got client functions, which act on the orchestration instances. Okay, so they'll start or restart the orchestration instances, and then they trigger from any source like HTTP or queue or event stream, and they have got an orchestration client binding in them. Okay, so those are different types of functions that you can use with the durable functions. Now, based on these, then there are different patterns available that we can make use of. So we have got function chaining, where you can chain different functions. You have got fan out and fan in, where you want to distribute the work and bring that work back in. And then you want to monitor the long running functions using the some kind of a monitor, or if you have got a human interaction, or if you want to aggregate. So there are different patterns that you can implement. So let's have a look at these patterns, how we can implement them. Now function chaining, it refers to the pattern of executing a sequence of functions in a particular order. So here we have got F1, F2, F3, F4. These are different functions. And we execute F1 first, and then we pass the output of that to F2, and then we pass the output of F2 to F3, and F3 output to F4. So we are chaining, right? Mm-hmm. So we can create this function chaining with the durable functions. Now to do that, I'm just going to open up the source code and I'm going to show you the function that I have got here. So this is, close that. Oops, I'm in the wrong place. I want to go here and I have got my hello sequence. So this is my code. Now in the code here, you can see this bit here is my orchestrator function. And in the orchestrator function, you have to have this durable orchestration context. Okay, so you have to have that. And then you can see here, I'm calling this say hello function multiple times. Now this is another function here that I have got. And I'm calling that function sequentially in this from this orchestrator function. So I've got another function which is this direct input that also I'm calling after this. Okay. Now to trigger this function, what I need to do is I need to call the specific function from a client function or a starter function. Okay. So for that, here I have got this HTTP start. And this particular function is the one which is going to initiate that orchestrator. Okay, so we are going to run this. I have actually deployed this already in Azure. So let me show you how this looks like in Azure. So I'm going to go to my Azure portal, and here I have my functions. Okay, and this is my durable functions. So in the functions, you can see I have got lots of different functions here, and you can look at the triggers. Now this hello sequence is the one that we are going to use for the function chaining, and you can see the trigger, it's orchestration. But to trigger that, we need to have this HTTP trigger, which is the HTTP start. Okay, so this is the client function, and this is going to trigger this orchestration here, which is our hello sequence orchestration. Okay, now for this, let's go to this HTTP start. Now this function, when I want to run it, I need to have this function URL. So I can get this function URL, and then I'm just going to post this in a notepad for everybody to understand. So this is my function URL here. Now here we have got the function website, and then see, notice here this orchestrators. Okay, so this is going to then call that orchestrator function that which we are going to pass in here in the function name. Okay, so we can make this call from the Postman, and I'm just going to open up my Postman here, and I have already added it in this section. So I'm just going to zoom in to show you. Here we can see that I have got here, this whole thing is basically the URL. So we have got these orchestrators, right? And then here I have got this sequence, right? So that's what we have. And then the code, which is the function key. So we are going to call that first, and I'm going to make a post call, and I'm going to click send here. So once I do the send, you can see here I've got the status URI. So I'm just going to zoom in again, and you can see here I have got the status URI. So this status URI, I'm going to use it to check what's happening with that function. Okay, so I need to copy this, and this is going to tell me what is the status of that orchestrator function. So let's enter that, and let's send. And you can see here we see this output, which is hello Tokyo, hello Seattle, hello London. So it's showing me that output there. Okay, so it was called sequentially. So that these three functions, they were called sequentially as per the code. So in our code here, we are calling, first we call this by passing Tokyo, then we call this one by passing Seattle, and then we call this one by passing London. And that's how we see this chained output coming in here. Okay, and the function status is it's completed. So this is how you can chain your functions.
Okay, nice.
Then we have got fan out and fan in. So this fan out and fan in refers to the pattern of executing multiple functions concurrently. So here I want to execute this F2 function multiple times and then performing some aggregation. Okay. Now you could do this in a normal function. If you want to implement it, this is going to be very complicated. Like you could fan out, but then fanning in becomes very complicated in that scenario. But with the help of durable functions, it makes it really simple. So here again, I'm going to show you the code of my function. So I want to open up this backup site content. So this particular function app, what this is doing is it's backing up the site content. Okay, now to back up, it's copying the files from the site folder to the storage account. Now there's going to be lots of files there, so it's copying individual files there, and then I'm once it all is done, I'm aggregating all that, like how much of the content was copied, like in terms of MBs for each of the files. So there I have got two functions. So first of all, I have got this orchestrator. Okay, so this is the start of my orchestrator here. And then first it's getting the list. So there's a function which is called as get file list. So this particular function here is actually getting the list of files. Okay, this one. And then here you can see that I have got this copy file to blob. Now this is being done multiple times. So here we are doing the fan out. Okay. And then here we are checking the status of that fan out, whether we have all the functions completed. Okay, so it's checking that. Once that is done, then it's going to here fan in. So it's doing the sum. That's your fan in bit. And then it returns that total byte here. Okay, so that's your fan out and fan in that's happening. Now this again, I have implemented this function in Azure, and you can go back to Azure here and we can see that I have got this backup site content, which is an orchestrator function. Okay, then there is a get file list, which is activity function, and then we have got here copy file to blob, another activity function there. Okay, and then I can make use of this HTTP star to use that. Okay, I can use that to start that function. Now again, we can go back to our Postman, and here you can see I have got this function that I'm calling, right? So backup site content, and I want to pass this. So this is basically the place from where the files will be backed up to my storage account. Okay, so I want to pass that. And if we go back to our function code, we have got here the root directory, so which we are passing in the input here. Okay, get input root directory. So I'm going to make this post call. Okay, now the post call has been done. And again, we can check the status by going to this particular URL. And I'm going to take that and post it here. And here it says that this failed. Okay, and it's giving you the reason as well. Okay, the process cannot access the file because the file is currently in use. So this particular file failed. Okay, but there will be still some files which are copied in there. So if we go back to our Azure function, we want to check out the storage account. Okay, so here we have got the storage account. Now one of the files, because I'm running these functions, that file is in use, so that is not getting copied, but we will have some other log files coming up in here. Okay, so other files are here which are copied. Okay, so you can create functions like this which are going to then fan out and fan in. And then we have got here another pattern, which is Async HTTP API. So this pattern addresses the problem of coordinating the state of long-running operations with external client. So a common way to implement this pattern is by having an HTTP endpoint trigger the long-running action. Okay, so you're going to redirect the client to that status endpoint that the client polls to learn when the operation is finished. So this is what we kind of implement in here. Like for example, when we go to the durable functions, so let's go back here. This is my durable function. This is my durable function here. So in the functions, when we call this HTTP start function, we are going to start that orchestration. And the orchestration can run for a long time. Now you get this URL, which is what you're polling, which is this one, which we get in the output, like here. So this URL is basically the endpoint that you are going to poll. Okay. So durable function provides you that built-in support for this pattern. So this simplifies or even removes the code that you need to write to interact with long-running functions there. Okay. So you can use this REST method to get the information on that long-running function. Then we have got the monitor pattern. So monitor pattern refers to flexible recurring process in a workflow. So for example, polling until certain conditions are met. Okay. So here I've got this code. I code monitor. Now this is going to check for a condition. So this bit here is basically checking for the condition where you are checking for the current end date and the end time. And then until that condition is met, it's going to run this code. Okay, so we have got three functions here. We have got this monitor function. Okay, and then we have got this get is clear and then send good weather alert. So what this one is doing is it gets the monitor requests consisting of a location to monitor and the phone number to which it will send SMS notification, and then decides the expiration time for the monitor. Okay, And then we have got this get is clear, which is going to decide whether there is clear skies at the requested location. And if the weather is clear, it is going to send this alert, which is send good weather alert. Okay, so this kind of implementation you can do where you are monitoring for some certain situation, and then you can send that alert there. Okay, and then you have got human interaction. So human interactions is when you want to get some kind of interaction. So let's say that you have got approval on an expense report and you want that approval to be processed within 72 hours. If it doesn't happen, then you want to escalate it. Or if it happens, then you want to do something else. Okay, so that kind of implementation you can do with this human interaction. So whenever a real person is involved in that automated process, the process must be able to send some notification to the person and then receive the responses asynchronously. So it must also allow for the possibility that the person is available. Okay, so this is where your timeout becomes important. So here I have got another scenario where I have got phone verification. So I want to implement phone verification. Okay. So in this scenario, phone verification is used to verify that the end users of your application, they are not the spammers and they are who they say. Okay. So that's what I want to implement using this human interaction pattern. So here I have got SMS phone verification. Okay, so this is an orchestrator function here that performs the phone verification process, including managing the timeouts and the retries. And then we have got send SMS challenge, which is an activity function that sends the code via the text message. Okay, so here this one is our orchestration function, which is calling the send SMS, and then it's going to check here. Okay, and in the send SMS one, we are just normally sending the SMS code here. But your orchestration function is waiting for external event, so the response to that SMS. Once you get that external event, then you are performing certain actions there. Okay, if you do not get the external event, then you do say that, okay, timed out, that kind of a thing. That's your human interaction.
So just quickly, mate, I was just going to ask, with all of these, I assume we've got somewhere where people can get example code on the different types of patterns that you're talking about.
Yes, so we will be sharing the links in the video, but there's lots of information on the docs.microsoft.com, and there are links to GitHub repos. So in the GitHub repos, we have got all these samples of these patterns on how you could implement these different patterns. So those links definitely will be sharing in the video.
Yeah, I'll make sure we put those in the the detailed section below for those who are interested.
Yeah, so there's lots of good information there, and docs.microsoft.com is the place to go for this, and there's heaps of information available. Samples are there as well in there.
Great. Thanks, mate.
And then finally, we have got this aggregator function. So this pattern is about aggregating event data over a period of time into a single addressable entity. So in this pattern, the data is being aggregated. It may come from multiple sources. Okay, it may be delivered in batches or it may be scattered over a long period of time. And the aggregator might need to take some kind of action on the event as the data arrives. And the external clients also may need to query that aggregated data. So that's your aggregator pattern where you might have different systems sending the events and your function is going to perform that aggregation there.
Is that possibly some sort of data transformation typically?
So here, when you say you are getting multiple events, these could be events, let's say, coming from either your event grid or some other systems from where you have got some events coming and you want to get all those and then do some kind of actions, perform certain actions.
So they might be just putting them in similar format before you put it into some sort of data.
Yeah, yeah. Mm-hmm. Yeah. So those are different patterns you can implement using your durable functions. And this is how you can then get that stateful experience in the stateless environment. Because functions by themselves, they are stateless. But with the help of this durable function extension, you can then implement all these patterns, which gives you that stateful kind of implementation.
That was awesome, Janhavi. Thank you so much. I know that a lot of the students I've trained in the past would definitely be interested in durable functions, and that was a really good detail on the types of examples of types of durable functions that you could use. So thank you very much for all of that. We've done 3 sessions with you now. I appreciate you taking out your time and especially trying to help everybody understand all the different types of functions and where you might use one or the other. So really hope you enjoyed that, everybody. Like and subscribe if you want to see more of these types of videos. Thanks again, Janhavi, for joining us. Thanks, mate.
Thank you for having me, George.
No worries. Anytime, mate. All right. See you, everybody. Bye.
Yeah.